So in today's video, we will be analyzing relationships of data in a scatter plot. Each of the 25 adult women were asked to provide her own height y in inches and the height x in inches of her father. The scatter plot below displays the results. Only 22 of the 25 pairs are distinguishable because some of the xy pairs were the same. The equation of the least squares regression line is y hat equals to 35.1 plus 0.427x. And these are all in inches. So part A, it asks to draw the least squares regression line on the scatter plot above. Now, a least squares regression line is an equation that is best fit for a set of data with the least amount of residuals between the observed and the expectant values. Okay, so the way I drew this least squares regression line is that I simply inputted this equation into the calculator. I went into the table and looked for the nearest whole values to plot onto the scatter plot right here. And then I just drew a straight line through it. Okay, so that is part A. For part B, one father's height was 67 inches and his daughter's height was 61 inches. Circle the point on the scatter plot above that represents this pair and draw the segment on the scatter plot that corresponds to the residual for it. Give a numerical value for the residual. So the point is 67 for the x value and 61 for the y value. And right here I have circled it. Drawing a line from the point to the regression line is the residual. That is the difference between the observed value minus the expectant value. Okay. Now to look for the exact value, you simply plug 67, which is the x value, into the equation, and you have an expected value of 63.709 inches. And remember to always refer back to the context, okay? So that would be the daughter's height. Y hat is the daughter's height, whereas the x is the father's height. Okay, that's the x value. So the residual is the observed minus the expected. Okay, this is the observed. Oh, I'm sorry. Whoops, that is incorrect. The observed is actually, no, sorry, that is correct. No, 63, no, never mind that. Okay, 61 would be the observed, right, minus the expected, which is 63.709 inches. They're both in inches, okay? And the residual would be negative 2.709. And that is the residual, okay? That is this distance right here. Now, moving on to part C. Suppose the point x equals to 84, which is the father's height of 84 inches, and y, daughter's height of 71 inches, is added to the data set. Would the slope of the least squares regression line increase, decrease, or remain about the same? So this is the x value and that is the y value. I've already plotted it, which is right here, and it appears to be on the regression line. So to make sure that it really is, what I did was I inputted 84 and 84 into the equation. Okay, this is the observed value. Okay, I inputted 84 in the regression equation and I got an expected value of about 71, so they are both the same, okay? And since the observed and expected values are the same, the residuals would be 0. And so the answer is that it would be exactly on the regression line, and so the slope would not change at all. Okay, moving on to part D, would the correlation increase, decrease, or remain about the same? Now the correlation is a technique used to measure and describe direction and strength of the relationship between two variables. Okay? And since it is on the regression line, it strengthens the positive and linear relationship of it all. Okay? So the correlation would increase. Now, to summarize it all, okay, we analyzed the relationship of data in a scatter plot. A least squares regression line is the best fit equation for a set of data that gives the least distances and residuals, which is the observed value minus the predicted value, okay? And then correlation is a technique used to measure and describe the direction and strength of the relationship between two variables, okay? And in this example, the two variables are the height of the father and the height of the daughter or the woman in inches. And always remember to refer back to in context to the inches, okay? And that summarizes the video for today, and thank you for listening.